Good morning, everyone. I gave in the last problem, in the last class, I gave this problem to solve on your own. Anyone has a solution for this one? What is the simplified expression for the output variable A, B, C, and D? Explained about the binary to XS3 ABCD conversion. And for XS3, what we have A, B, C, and D. Right? Those are the four output variables. And we wrote the mean term equations and the don't care conditions for that. What are the simplified expressions for A, B, C, and D? Anyone? You can put it in the chat room. The answers you can put it in the chat room. What is simplified expression for A, B, C, and D? Anyone, did you solve it? You take the 1 day of time, maybe on Thursday again. I'll say ask about the A, B, C, and D simplified expressions. Everyone, please solve this one. In today's class, what we'll do is we'll study about how to simplify the maxterm equations using K-map, right? Till now, if you see for the 3 variables, 4 variable, the don't care conditions, what we studied, in all the examples, what we studied around some 21 problems, what we saw, 21, 22 problems, what we saw is with respect to mean terms, the mean terms was given to us, right? And we know how to substitute the load those values into the K-map, whether it is 3 variable or 4 variable, right? Once you load it, you know how to group it, group the mean terms. What is the rule for grouping of mean terms? We look for logical adjacency, right? Once you know that the mean terms are logical adjacent, you group, you make a group of 2, you make a group of 4, or you make a group of 8 depending on the logical adjacency, right? And accordingly the 2 or 3 variables are eliminated, right? Right. And also we studied up the don't care conditions, right? How we can use the don't care condition to our advantage, right? If the don't care conditions help us in creating larger groups of mean terms, we consider the don't care term as logic 1 and we group it, right? Similarly, if it is not helping us in creating larger group of mean terms, we consider the D as logic 0 there, right? We studied about, till now we studied that for a mean terms, it is all with respect to the mean terms. Now we'll study how, if a max term is given to us, right, how to simplify the given max term equations using K-map, right? The first, if you see, since we know about the mean term, how to simplify that one, right? Here also, instead of, if you see in the mean term, what we have is we used to load the value as logic 1 for whatever the decimal notation is given, or from looking at the truth table, what we used to enter, we used to enter the input combinations for which the output is logic high there, right? Now here what we do is, in max term, what we do is we load and group the max terms exactly the same as loading and grouping mean terms, right? The loading and grouping of the max terms is similar to the loading and grouping of mean terms. In mean terms, we used to enter logic 1 there. Here, for max terms, we enter logic 0 here. Into the K-map, we enter 0 here. for the max term. And also we introduced to the some of the terms called prime implicants and essential prime implicants, right? Once you load the value as 0, right, you group the max terms. How do you group the max terms? Depending on the logical adjacency. It is still logical adjacency, and once you group the max terms, you look for prime implicants and essential prime implicants there. But how do you read the k-map is different from how do we read the max term equations there, mean term equations, what we saw, right? I'll explain about how do we read it. We know the difference between mean term and max term because I think in the couple of classes before I explained how to write the equation from the two table, how to write the mean term equations, mean term and the max term for the given two table. I've explained that one, right? The same thing, the reading for the mean term we know it, the reading for the max term also we know it, but I will re-emphasize the same what we know it while simplifying the k-map for max term equations. Okay, right? Everyone understand here? In max term what we do is we load zeros. The loading and grouping is similar to the mean terms what we have, and we look for the prime implicants and essential prime implicants, right? How do you make the group of mean terms? As I said, logical adjacency. I'll explain how to read the k-map for max term equations. Okay, now first we'll see one example. Simplify the following max term equation. Now what is given? The output variable j is equal to the function x, y, z, right? We have three input variables x, y, z, which is equal to pi. Pi is nothing but what? What do you understand by pi? It's max term. If it is a summation symbol, we know that it is a mean terms. If it is a pi symbol, it is a max terms. So that what we have, mean max term 0, max term 3, max term 4 and max term 7 here, right? Now here for these max terms what we have 0, 3, 4 and 7, we substitute in j k-map as 0 there, right? And rest of the values are logic 1 there. Everyone understand this one, right? Since it is the symbol which is given to us is pi here, it is nothing but max terms which is given to us. So that the max terms 0, 3, 4 and 7 are logic 0 for j here. Now the first thing what you need to do is, as I said here, the loading and grouping of the max terms is similar to the mean term loading and grouping. The first thing, draw the three variable k-map. That still remains the same, and the decimal value what we enter into the k-map still remains the same there, right? Since we have three variables, input variables x, y and z, draw the three variable k-map first, right? Now load the max terms into the k-map by placing a 0 in appropriate square. In which appropriate square you place 0 here? Which is given in the equation 0, 3, 4 and 7, right? For these max terms the j is 0, right? Accordingly what we have done here, 0 decimal value can 0, it is 0 here, the decimal 3 is 0, the 4 is 0, the 7 is 0, right? What about the rest of the terms? We have 1, 2, 5 and 6. All these are equal to logic 1 here, right? As I said here, if you want, you can write it as logic 1, or else you don't have to write it. It's up to us. Some of the authors, they write explicitly logic 1 there. Some authors they don't write it, right? It is up to us. The main thing is, since it is max term equations, enter 0 and group those max terms, right? That is very important here. Now, how do you group it now? How do you group this one now? Logical adjacency, we know that, right? How do you group this one now? Anyone? Since we studied about the max term before, now what we have? This 0, these are logical adjacent because there is only one variable change between these two, right? We have 0, 0 and 1, 0. Again, what we have? These two are adjacent to each other, correct? Right? The grouping, the loading of the 0 terms and the grouping of the the zero terms is still the same as mean terms, correct? In mean terms, we used to group one terms there. Here, the mean terms there. Here, we used to group the max terms here, right? Now, once that is done, how do you write this one now? Logical adjacency is done. You know the number of prime implicants what we have now. We have two prime implicants here, right? We have two prime implicants here. Now what we do, we have done. Now here, as I said here, the reading of the max terms is different from what we used to study. Like what we did for the mean terms. The reading is different for the max terms as compared to the mean terms. Now what you do here, now here I've written at the bottom 2 points. The max terms are read as if input n is a 1 for all max terms in an EPI. EPI is nothing but essential prime implicant, then it would be read as n bar. In the sense, if you see here what we have is 0, 0 and 1, 0 what we have it, right? Normally if we take an example that if it is a mean term, consider that if it is a mean term, consider that if it is this is 1, this is 1 and this is 1 and this is 1. How is to read this one? How do you read this one now? Right? Both are logically adjacent. How do you read 0, 0, 1, 0? What is common? Y bar is common here. Right? For logic 1, we used to read like that. For the mean terms, we used to read like this. Similarly, for this one, how do you read it now? 0, 1, and also if you see what is common here, z bar, right? Z bar is common here. Similarly, what we have 0, 0, 0, 1, 1, 1. What is common here? Y, right? And here it is z. What we have is this one, y bar, z bar, or y, z. If it is a mean terms, right? If we are grouping the mean terms, when I say mean terms, all these mean terms are logic 1, right? But for max terms, how do you read it? How do you read for the max terms here? If input n is a 1 for all max terms in an essential prime implicant, then it would be read as n bar. In the sense, what you call it as 0, 0, 1, 0, right? Now, which is common term, what we have it? 0, right? That what is, if you see the second point, if the input n is a 0 for all max terms in an essential prime implicant, then it would be read as n. So that what you read it now? 0, 0, 1, 0. 0 is nothing but y. Since it is 0 here, you read it as y here. You read this one as what now? Y here. Understand? Y, right? And also z, what we have it as 0 or z here. Understand this one. If input n is a 0 for all max terms in an essential prime implicant, then it would be read as n. The one point I want to highlight it again is that we know that the max term is nothing but what? The complement of the mean terms, right? If you see this one, what is this one what we had, right? If I take the complement of this one, what we get? What we get then? Pi bar and z bar, correct? Right? This is one of the terms what we have in the simplified mean term expression, right? And this is what we have for a max term in the simplified max term at the pos equation there. Everyone understood this one? If you see the truth table, how is to write for this one? 0, 0, 0, right? If you see the truth table for this one, how is to write this one? 0, 0 and 0. If it is a mean term, how do you write the mean terms? I'll write it as small m, capital M as right? Now how do you write the mean terms for the mean terms? How would you write? A bar B bar and C bar. Take the complement of this mean term, what you get now? When I say complement of that, what you understand by that? A bar, B bar and C bar. Apply the De Morgan's theorem, what you get now? A bar whole bar, right? Or B bar whole bar. In the sense, what we get now? This one bar or right, or what we get now, apply the De Morgan's theorem, what we get now, C bar. Double complement is nothing but what we know, it is nothing but A or B or C. So that what is the max term, how do you write? A or B or C here. Correct, everyone understood this one? Everyone remember the table what we discussed, this one with respect to the mean term, when I explained the mean term and how to write the max term equations there, right? It's still the same here. If it is 0, we write it as n. If it is 1, we write it as n bar, right? When I say max term, it is nothing but the pos term, product of sum term. When I say mean term, it is nothing but sum of product term, the SOP form there, correct? So that what we have it now here, what is the expression we have it now? This one then, 0 0 1 0, y or z, because y is 0, z is 0, right? If it is 0, we read it as n, right? Here the variable is y, here the variable is z, right? Similarly, what about this one now? What we have? 0 1 1 1, right? Which is common here, the y is 1 here. If it is 1, we read it as n bar. N bar is nothing but here the variable is y, so that we write it as y bar, or right, now what is common? Again, z is 1. Since it is 1, we read it as z bar here. Understand? Max terms are nothing but pos form, mean terms are SOP form. Understood? So that what is the expression we have it for this one? The simplified expression what we have? J is equal to y or z, y bar or z bar. Everyone understood this one? Any confusion you have it? How do you read it? The max terms here? If you have any confusion, right? Normally, what will happen is that we are more used to the mean terms, right? We know easily we can write the mean terms because we are used to that. It's something like decimal numbers. If someone say you to the count, decimal count, say 1 to 100, you can easily say that, right? If someone says you to count 1 to 100 in hexadecimal or a decimal or in Greek code or some other code, it is a little tricky for you because you're not used to that, right? It needs little bit of practice, right? Now, take an example. If you have any confusion, the one trick what I want to say is that if you have any confusion in writing this max term, the one thing what you should remember is max terms are nothing but what? The complement of the mean terms. Take an example. You grouped the 0 here. How do you used to write the mean term equations? How do you used to write the mean term equations here? I'll give you one idea how, if you are unable to come with an max term, what you can do here is group like mean term only. What we used to write 0 0 and 1 0. What we have is 0 y, so that how do you write the mean term then? Y and y bar z bar, or what we have here, y and z. This is a simplified expression in SOP form. Now take the complement of this one. If I take the complement of this one, what do you get now? Take the complement of apply the De Morgan's theorem for this one. What do you get now here? Y bar z bar whole bar, right? The or is replaced with an and here, right? Again, what we have, y and z bar here, correct? Now this could be written as what now? Now again apply the De Morgan's theorem for this one. What do you get now? Y bar whole bar, or what we get here? Z bar whole bar, right? Dot and what we have it here? Again apply the De Morgan's theorem. Y bar or Z bar, right? So that what is expression we get here? You can see from the double bar is nothing but the same variable. Double bar is nothing but this one, Y bar or Z bar, right? We got the same equation here, right? If you have in confusion how to write the mass equation, what you can do is try to group as same as the mean term, how you used to do it, and take the complement of that. When you take the complement, the expression what you will get is nothing but the expression in product of sum form. Understand this one? Any confusion here? Anyone? Any confusion you have it here?
No, sir.
Okay, that's good. We'll go to the next problem. Everyone note down this one. Simplify the following max term equation. Simplify the following max term equation. If it is max term is not given also, if they say something like simplify the equation or minimize the equation, right? Just by looking at the equation, you know whether the max term is given or mean terms are given. How do you identify? If summation symbol is there, you know that it is a mean term. If it is a pi symbol is given in the equation, you know that these are max terms. Right. Now what we have, the output variable g is a function of input variables a, b, c and d, which is equal to what? 0, pi. What we have? What are the max terms we have? It 0, 4, 5, 7, 8, 9, 11, 12, 13, 15. Right? Now for these max terms, you need to enter in the K-map app 0. Since it is a 4 variable K-map, everyone draw the K-map for 4 input variables A, B, C and D. We should have 16 cells. Does decimal value still remains the same and the horizontal values for the variables and the vertical values for the input variables still remains the same there. Okay. Now first everyone draw this one. Now since the max term is given, what you need to put here instead of, if it is a mean term, is to write logic 1. Since it is a max term, we enter logic 0 in the appropriate squares of the K-map there. Right? Now look at the equation and load the max term values into the K-map there now. Now make the group now. How do you make the group for this one? Look for logical adjacency. Please use the max term expression now. Everyone do it. The grouping, everything is still the same, but how you read the values is different for the max term as compared to the mean terms. That's the only difference what we have it. You can put the answers in the chat room. Yeah, that's good. Stuti, yeah, Stuti has been trying. She got the answer. Anyone? Good to see students trying at their end. This makes faculty happy because the students are also putting the efforts at their end. So that how many? As I said, how do you read is different here. Now, how many groups do we have it here? Three groups, right? We can go for four groups here because all are logically adjacent, right? And how do you read it? As I said here, if it is 1, you read it as n bar. If it is 0, you read it as n, right? Accordingly, now do it. What is the equation? The first one, what we have it here, and what is common here? CD 0, 0. Since it is 0, 0, what we have? C or D, correct? Right. Similarly, what we have for this one? What's the common term we have it? 1, 1, 1, 0. It is 1 here. 1 is A. A is, since it is 1, A bar, or how do you write this one? Which is common here? 0, 1, 1, 1. 1 is the common which is for the variable D. Since it is 1, we write it as D bar. That's correct, right? Similarly, what we have it here for this one, you can write it as what now? 0, 1. Again, it is what we have it here. D bar is common here, right? Plus, and what we have? 0, 1, 1, 1, right? B is 1 here, so that you write it as B bar here. That's correct, everyone? Right? And also, if you see here, now I can see students writing, identifying the prime implicants very correctly. They know it. Okay, these are the prime implicants, and these, what are the prime implicants? We see they are essential prime implicants. Take an example that now the students are not grouping this way, right? Now they are not grouping this way, right? Right? Understand here. It's good because since we know we solved many problems. Now we can easily identify just by looking at the K-map itself. We know how to identify the prime implicants. We got used to that. I think that is a good development. What I can see in the students. That's good. Everyone got the answer here. So that the Shruti has written, the Megha has written. I think she has Megha has forgot to write the other term here. The whatever the two terms Megha has written is correct. C or D, B bar or D bar, and the other term what we have is A bar or D bar. That's good, right? So that what we have it here, the simplified expression in product of some form is C or D, B bar or D bar, A bar or B bar, right? We'll go to the next problem. Everyone write this expression. We'll go to the next problem here. Simplify the given function. Simplify the function. The output variable t is a function of input variable w, x, y, z, which is equal to the pi, right? 1, 3, 8, 10, 12, 13, 14, 15. The max terms are given to us, right? Accordingly, load the values into the appropriate square as logic 0 because all these are max terms, right? 1, 3, 8, 10, 12, 13, 14, and 15. Everyone draw the four variable K map. The input variables what we have is W, X, Y, and Z. W is the most significant variable and Z is the least significant variable, right? The way we used to draw the K-map for the mean terms, the max terms, is everything is same. The only difference what you should remember is that for max term we enter 0, for mean term we enter 1. How do we read the simplified, the mean term expressions? The terms what we read is different for mean terms and the max terms. Now load this value, what we have it, 1, 3, 10, 12, 13, 15, 14. Now everyone put the simplified pause terms in the chat room. Okay, the Stuti has given the answer, W bar or X bar, W bar or Z. Okay, it's good. Anyone has answers? As I said here, you should always go for maximum number of max term group or the maximum number of mean term group now. So you can see that this what we have 0 these we cannot combine this group of max terms with any other thing. Similarly, what we can have, we can see here all these are logically adjacent, right? This is one of the prime implicant. Again we have, you can see here this one and this one, so that what we have, the three prime implicants, what we have it here correctly, everyone. Right, we have the group here, but how do you read it? As I said here, if it is 1, read as n bar. If it is 0, read as n there, right? Now how do you read this one? What we have here, you can 0 0, and what is common, 0 1 1 1. What is common here? Z is 1, W and X are 0 0. Since it is 0, what, how do you write? W or X, and Y is 1, so that you read it as Y bar there correctly. Similarly, what we have for this one now, how do you read this one? 1 1 1 0. What is common here? 1. 1 is for the variable W. You read it as what? Since it is 1, you read it as W bar. Or what is common between these two? 0 0 1 0. 0 is common. 0 is the value for Z. Since it is 0, we write it as Z there. Similarly, for this one, what do you write now? What is common? 1 1. So that how do you write? Y bar, W bar or X bar. Correct, everyone? So that what is the expression we have it. Yes, I not removed this one, I just kept it the same, the previous one. You can see here what we have, W or X or Z bar, W bar or Z, W bar or X bar here. Correct? We'll go to the next one. Any confusion? Everyone note down this, the simplified SOP expressions. G, what we have is J is equal to W or X or Z bar ANDed with W bar or Z ANDed with W bar or X bar there, right? Now simplify look at the fourth problem. Find a reduced pause form of the following equation. Anyone can tell me the difference? How is this problem different from the other problems what we studied today? Anyone? Unmute yourself and tell me.
Sir, they are given mean terms here.
Yes, absolutely. Who is that? Sorry.
Rohini, sir.
Rohini, yes, what Rohini said is absolutely correct. What is given to us is a mean term here. If you see from this equation here, we have summation symbol, right? It means that what is given is a mean terms, right? And also what is given is don't care conditions, 0, 2 and 5. Now what he says, the mean terms is given to us, but what we need to find here, we need to find a reduced pause form, right? The reduced max term equation, what we need to come with the product of some form, what we need to come with this one, right? That's the reason I've highlighted here saying that read the question carefully. The summation is given means it is of the mean terms, right? And also whether it is a mean term or a max term, the don't care conditions what we have still remains the same, right? It is still D. If we can go for maximum number of mean term group, if I include the don't care condition, for max terms we consider that as 0, for mean terms we consider that as logic 1 there. Understood? So that now since we need to come with a reduced pause form, what you do here, we know that for decimal values 1, 3, 7, 11 and 15, these, for this one, the function what we have which is written here, it is equal to logic 1, right? And for these decimal values 0, 2 and 5, it is equal to don't care terms. It means that it is equal to D or X there, right? And also what information you get from this one, we know that other than the terms which is specified in the equation, those decimal values is equal to what? 0 there, correctly? Everyone, right? The values other than this, you can see here 1 is given here, 0 is there, 1 is there, 2 is there, 4 is there, but 3 is there, 4 is not there, decimal value 4 is not there. So that what value you put it for 4? You put it as 0, right? 5 is not written, so that in 5 what you write it? You write it as 0. 6 is not given, it is not mentioned in the equation, you write it as 0 there. 7 is given, 8 is not given, 9 is not given, 10 is given. So that what values you enter in the cells 8, 9 and 10, you enter it as logic 0. Similarly, what we have 12, 13 and 14, right? In all this 12, 13 and 14 cells, what you write it? You write it as logic 0, right? The sense what I'm trying to say here is that whether it is a mean term is given or max term is given, just by looking at the equation, you know in which cell we need to enter logic 1 and in which cell we need to enter logic 0 and which cell we need to enter don't care terms. Just by looking at the equation, all the information we can easily enter there. Correctly? Right? So that what you do now? Now the first thing what you do, now you come with, if you see here, now change this one, guys. This is not a summation, change it as this as pi. Now what I've done is just now I commit the max term equation by just looking at the mean term equations what we have it, right? Yes, just a 5 minutes time what we have it. We'll try to wind up soon here, right? Just a minute. I cannot remove this one unless until I click on this one. This is nothing but pi now. But just by looking at the equation, I come with the max term. We know that 4 is not given, 6, 8, 9, 10, 12, 13 and 14. All these decimal values what we have in these cells, I write it as 0. These cells I write it as D there. Understand? Now I come with the max term equation by looking at the mean term equation there. Right? Now what you do, accordingly in these decimal cells, substitute the value as 0 there. Substitute the values there, 0, 0, 0, 0, 0, 0, 0, 0. Right? The cell 0 is D, the cell 5 is D, the cell 2 is D. Now make the grouping now. Everyone make the group now. How do you make the group now? Anyone have give the answer in the chat room? Identify the number of prime implicants. Now I can just by looking at this one, we know that we can group this correctly. And also you can see here, this is don't care terms, right? Since it is don't care, there is no need for us to include this term, right? Or unless until if I include this D term will help us in creating larger group of main terms. Now what we can do, since we know that 13 and 9, I can group with this one, right? So that I have a group of 8, 12, 13 and 9 max terms here. So that we have two prime implicants here, right? What is the expression then for this one then? What is the expression for this one? We grouped it this way. We know how to read it. How do you read it now? As I said here, if it is 1, read it as n bar. If it is 0, read it as n. Similarly, what is common here? You can see here 0, 0, 1, 0. 0 is for the variable d. So that you read it as d here. And what about this one? 1, 1, 1, 0. 1 is for the variable a. You read it as a bar. Yes, Stuti has given the right answer. Right? Anyone has the answer, please put it in the chat room. So that what is the answer? We have it D ended with A bar or C. That absolutely correct. Whatever the Stuti has given the answer, that is correct. Any confusion here? How do you read the max terms? How do you the pause, the simplified pause expressions? How to come with the simplified pause expressions?